Okay, for this example, I'm looking specifically out of section 1, chapter 2, section 1, at example 2. I'm finding it on page 61. It's got two parts here. We've got two different types of inequality problems, and we're looking primarily right now at its solution set. So I'm going to go quickly through how to solve, but really spend most of my time talking about what it means to have no solution as an answer or all real numbers as an answer. So I'm just going to remember that when I have an inequality, I'm essentially going to treat it like an equation, equal sign, while I follow the process for solving for x. All right, so what you'll notice is that the first step that I took was to distribute the 2 into the 3 and the 2x, so I get 6 plus 4x. Then I'm subtracting 4x from each side in order to cancel here. What I notice is that the canceling here leaves me with 0, and the canceling here leaves me with 0, so my solution is 0 is greater than 6. I'm thinking to myself, 0 can never be greater than 6. Whenever I run into this situation with an answer such that the answer reads an illogical statement, that means that I have no solution as my answer. On a number line, I would simply draw out a number line and shade nothing in because no number is included in my solution set. Now let's look at this other part to the example. Got a new inequality, and I'm going to follow similar steps that I did over here and just quickly come up with my solution. All right, so again, I distributed this negative 1/2 into the 6 and the 4, remembering that multiplying by 1/2 is the same as dividing by 2, so negative 6 divided by negative 2 is positive 3, 4 divided by 2 is 2. Now, in order to cancel this 2t on this side, I'm subtracting on both sides of the sign, and that leaves me with 0 on the left and 3 on the right. Now, I read this 0 is less than 3. That's always true, always true. When I run into a situation like this, where I have always true, that means that every number will work. So, my solution is all real numbers. Okay, so when we're looking at a number line here, a number line or graphical representation of these solutions, for no solution, I simply leave the number line blank. I can't shade anything in because I have nothing in my solution set. Alternatively, when I have all real numbers, that means that everything is in my solution set, so the entire number line gets shaded. Okay, now I'm looking in section 2 of this chapter. Specifically, I'm looking at page 67. The examples are in the book are rather straightforward, and they're the ones that we went over in class. But really, I want to look at some of the written exercises. So they give some solutions that I think are interesting and worth really diving into. So I'm looking at both number 7 and number 8. Let's look at number 8 first. First, let's remember that and is the conjunction here. And let us also remember that conjunction, or and, means that I'm looking for the overlap of the solution sets, which is just like in our Venn diagram representation. Our solution set is right here in the overlap. Okay, to get started, I'm just going to look simply. These are nice examples because I don't have to solve anything. I already have sort of the solution written out in simple form, but I need to figure out graphically what really is going on. Where does my actual solution lie? In order to do that, I'm going to graph each of these individually and then put the combination that's appropriate on the number line. So let me just make this number line a little bit bigger as we're using it here. I'll move this one out of the way. A little bit bigger. Okay, so I'm looking first at this w is less than 0. W is less than 0. So I'm going to put a little circle above the 0 and shade to the left. W is less than 0. Okay, now I'm then going to look at the w is greater than or equal to 4. So I'm going to circle the 4, shade, and then shade in this direction. Now I'm going to remind myself that we have an and here, which is a conjunction. It means I'm looking for the overlap. And I notice that there is no overlap between these two graphs, which means that there is nothing that I can shade on the solution graph, right? Nothing that I can shade. So when I can't shade anything, right, so no shading, right, or no overlap, that means that I have no solution. Now let's do a similar thing for number 7 over here. I'm going to remember that or means disjunction. And for this, I'm not looking for overlap. It's anything that exists, right? So anything. Right? I'm not looking specifically for overlap. So again, thinking about our Venn diagram, for a Venn diagram, the solution set for or is anything that falls in the circles. Okay, so as I graph this, I'm just going to make the number line here a little bit bigger and make it easier to work with. And then I'm going to look specifically at this t is greater than 0. All right, so I'm going to circle 0, open circle, because it's not equal to, and then t is greater, so I'm going to shade to the right. Okay, and now for the second one, I've got t is less than 2. So I'm going to open circle, shade to the left. Now what I'll notice is that there is this overlap here. And where 2 does not exist in this part of the solution, it does exist here, right? And so since these two lines fill in for each other, in other words, all of these numbers, all the way up to just past 0 are taken up by this solution. They're covered. They're in one of the circles. And all of these numbers, all the way to 2, just below 2, are taken up by this selection. It's in this circle, right? So when this occurs, when this happens, that means that every single number exists in the solution set. So I'm going to shade my entire arrow. In other words, my solution is all real numbers. So again, I'm just going to reiterate that in number 8, the reason I have no solution is because I'm specifically looking for overlap. With an and, I have to have an overlap. It doesn't exist here, so I have no solution. Now with ors, with my disjunctions, anything that exists in one of the two solution sets will exist in the final solution set. So where this first arrow is missing, the second arrow fills in. Likewise, where the second arrow is missing, the first arrow fills in. Therefore, my solution set is the entire number line, all real numbers. Now I want to look at 2 more problems, again from page 67. I'm looking at 4 and 5 in the written exercises. Here the solutions, again, are a little bit different. They're not, in this case, they're not no solution or all real numbers, but they do have to do specifically with overlap and anything. Okay, making a number line for number 4 here. I'm just going to look at this p is greater than 1. So circling 1, going greater than here. And then the second part says p is less than 1. So circling 1, going less than. All right, now I've got this disjunction, the or, here. And to me that means that anything, anywhere the line exists for the solution set, that's in my answer. And when I look closely here, I notice that all of the numbers in this direction are covered, all in this direction are covered, but the number 1 has an open circle for both parts here. So what that means is in my final solution I have an open circle around 1, and then I shade in on both sides. So here my solution is, in formal notation, is P is anything except for 1. It cannot be 1. In shorthand it would look like P cannot be 1. All right, now let's look at number 5. The first part of number 5 says y is greater than or equal to -1. So I'm going to circle -1. I'm going to fill that in because it can also be equal to. And then y is greater than, so I'm going to shade in this direction. Now I'm going to look at the second part. Y is greater than or equal to 3. So I'm going to circle 3, shade it in, and then shade greater than 3. Now what I'm going to remember is that I'm looking at and. And is my conjunction, and it means that my solution is wherever overlap occurs. And I notice that I've got 2 lines starting at 3. So my overlap starts at 3, includes 3 because of that closed circle, and extends to infinity. So my solution set then is going to look like circling the 3, shading it in, and then shading to the right. Writing this out, it's going to look like, in formal notation, it's going to look like y, the solution for y, such that y belongs to all real numbers greater than or equal to 3. In shorthand, it's going to look just like this. Y is greater than or equal to 3.